Bonjour, and welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. Make sure that everyone knows how to participate live if they choose. You can call the Wahsa studio at 1-800-465-7144 or at 737-4017. You can call and ask questions if you have them. You can listen to the radio at 91.9 FM or on the television at Bell Express View channel 972. You're also welcome to participate through Zoom by clicking on the link that you have received from your teacher and is available through your GEC, and you can join us asking questions there. I've turned on subtitles, so just so you know how to access them if you need to. You can go click down to the More button if you're joining us through Zoom, and then either click the Hide or Show subtitles, depending on what works best for you. Our classes are Monday through Thursday from 11 till 12 a.m., and we are in week 1 of our 9-week course. Reminding you what work to submit for marking. The support questions, the ones marked with the pencil icon, are not for marking. Those are ones just for you to practice. You decide which ones and how many of them to do. If you understand the concept, feel free to skip them. Don't spend time on something that you're feeling really comfortable with. If you need more practice, let me know and I can help you out. The answers are in the back of your workbook, so check your work to make sure you're on the right track. Sometimes answers are wrong or questions have typos, so let me know if you find any errors. The key questions marked with the key icon are the marked questions. So please do all of them and show all your steps in your thinking so I can give you credit for the understanding that you do have and make sure that you aren't just losing marks because of calculation errors or small mistakes. How to submit your work for marking. The first method is to scan and send your work in electronically. You can scan your completed work through the iPhone Notes app or the Android Google Drive app. Then email your work to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can Facebook message it to me at bslatewahsa. Second method is to drop it off in Lookout. We have an outdoor mailbox at 74 Front Street at the side entrance. We are the big red building next to the post office, and there's a small white mailbox next to the side door. Because we're working remotely, I won't get it immediately, but I will get it fairly quickly and get back to you as soon as possible. 3 is to hand in your work to your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. As always, if you have questions or concerns, please contact me. My email is bronwyn.slate. That is spelled BRONWYN.SLATE at nnec.on.ca. You can connect with me on Facebook at bslatewahsa. You can call the office and leave a message for me there at 807-737-1488. The best way is to leave a message with the front desk. Call toll free there as well, 1-800-667-3703. And my office hours are Monday through Friday, 8 a.m. to 2 p.m. And I'll get back to you as soon as I can. Connecting with me through Facebook and social media is a great way. Subscribe to my YouTube channel, my Facebook, they're both under the name bslatewahsa. Every radio Zoom class will be posted shortly after airing, and I also have other videos explaining and confusing concepts on my YouTube channel. So it's a great place to go if you are struggling with concepts. If you have specific things you'd like me to add there, please let me know, and I'm happy to do videos so that you can refer to them at a later date. Math is a very visual subject, so if you're able to connect either through the Zoom classes and see it live or watch the replays on YouTube, I strongly suggest that. Today and tomorrow's examples are very, very visual to really understand what is going on. And so connecting with the video is going to set you up for the most success. All right, we are on day 3 of our MBF3C course, and we are starting to look at lesson 2, polynomials and factoring. This lesson is going to take 2 days. Our learning goals for this lesson is, I hope that you can say, I will understand and implement the distributive law, and I will be able to factor trinomials. Success criteria to be able to know that you've met those learning goals, because you can say, I can explain and identify polynomial terminology, I can multiply binomials, and I can common factor and factor trinomials when a equals 1. So there's a lot that we're going to be covering in this lesson. But first, we want to activate our brain and get going. As we've talked about before, mad minutes were something that many of us experienced in elementary school, and they didn't reinforce any learning. They just caused a lot of stress, and either you knew you had your facts memorized or you didn't. And so that's not how we are approaching our brain activation, our mental math. Instead, we are learning strategies, remembering strategies, applying things that we already know in order to attack various problems. 6 times 14 is the problem we're going to be looking at today. This is not a fact that I memorized when I was an elementary school student. I was told to memorize my 0 through 12 times tables, and I did. That was something that was comfortable for me to do. But as soon as I hit 13 or 14, I didn't have any strategies. I didn't know what to do with those numbers. They weren't facts that I had done flashcards and done over and over and over again. And so I had no tools to deal with that. But the fact of the matter is that I do have the tools. I just wasn't told how to use them. So we're going to do something today that's called partial products. And really what we're going to be doing is breaking our number into friendly numbers. I talk a lot about friendly numbers when we're doing brain activation, because that's really, really important. So looking at 6 times 14, 14 really is just 10 plus 4 groups, right? So we're saying we have 6 groups of 14, could be one way that we're thinking about it. And so really we could say that we have 6 groups of 10 and 6 groups of 4, and that's going to be the same amount overall. So if I think about it like that, I know what 6 times 10 is. That is a fact that I do have memorized and is fairly comfortable for me to think about 6 groups of 10, count by 10s, 10, 20, 30, 40, 50, 60. 6 times 4, another fact that I do have memorized, is 24. I can count by 6s or by 4s to get that if I don't have it memorized. So if 10 plus 4 is 14, then 6 groups of 10 plus 6 groups of 4, I can add those two numbers and I get 84. That's what 6 times 14 is equal to, is 84. So breaking it up into numbers that are friendly and attainable for me means that I don't have to memorize my 14 times tables. I don't have to memorize my 16 times tables, my 17 times tables, my 24 times tables. I can use the facts that I do know, so they were useful, but I can use those facts to be able to break up the numbers into friendlier numbers and use that information to find facts that I don't have memorized. All right, mine's on. We're going to engage in prior learning. We're going to remember things from the past. So we're going to go again back to elementary school multiplication, and we're going to look at what's called the area model of multiplication, just to connect this to what we're doing moving forward. So 3 times 4 means 3 groups of 4 things. So we have 3 groups of 4 things when we think about multiplication. So 3 groups of 4 things is 12. 3 times 4 is, we could think of as 3 things in 4 groups. So we could also think of it as having 4 groups, which each of those groups is now having 3 things in them. And that still gets us to 12. So it doesn't matter if we have 3 groups with 4 things or 3 things in 4 groups, we have the same amount. It doesn't matter the order that we multiply or the way that we think about them in terms of our groups or our items within our groups or objects. So the area of multiplication is organizing that a little bit. So taking our 12 and organizing them in straight columns and lines. So we have our length of 3 and our width of 4 is a way we can think of organizing those rows and columns, those groups and those things we can think of as a 3 times 4. So thinking about how that area model works is that we can think about how we can line up our numbers and break up our numbers. Is if we have 5 times 9, say we don't have this memorized, which is fine, we can think about it by breaking up our 9 into smaller pieces that we do know. So 5 times 9 is the same as 5 times 1 plus 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 1. I hope I said that 9 times. And that's going to give us the same thing. So if we were to count that by 5s, this is sort of what we're doing. So 5, 10, 15, 20, 25, 30, 35, 40, 45. You can't see me, but I'm using my fingers to keep track. So 5 times 9 is equal to 45. Another way to think about that is to break 9 up into groups of 3. So 9 is 3 plus 3 plus 3. So 5 times 3 plus 3 plus 3, we can think of as 5 times 3 is 15. So 15 plus 15 plus 15 is going to be 45. Or we could break up 9 into one group of 5 and one group of 4 and think of it as 5 times 5 plus 5 times 4. And so we have 5 times 5 is 25 plus 5 times 4 is 20 equals 45. So then taking more complicated numbers, we have 17 times 23. Again, not facts that probably any of us have memorized. And we can sort of organize them again in that area model to think about how we're arranging, how we're visualizing our numbers. So this isn't an exact, but I have 17 times 23. I'm thinking about how can I break up those numbers into be friendlier numbers. So I can do 17 can be 10 time plus 7, and 23 can be 10 plus 10 plus 3. And from there, we can then break those up into amounts that are friendlier. So 10 times 10, if we think about that as a organizing all of our little unicorns like we had before. I'm not going to draw a row of 10 unicorns and columns of 10 unicorns, but that amount, the equivalent, would be 100. And again, 10 times 10, that amount would be 100. I have 100 unicorns in here. And then 10 times 3, I would have 30 unicorns in there. And then here, 7 times 10, I would have 70 unicorns. And again, 70 unicorns, 7 times 10 again. And then 7 times 3 is 21 unicorns. So we can take quite large numbers and multiply them this way. But now we need to figure out how many unicorns we have in total. And so we can add up the groups that we have. So 100 plus 100 plus 30 plus 70 plus 70 plus 21. So I'm going to say, okay, I have 100 and 100, that's 200. I know that 30 plus 70 is another 100, so I have 300. And then 70 plus 21 is going to be 91, so I have 391. So 17 times 23 is 391. I've got 391 unicorns. That's a lot of unicorns. Okay, so we're going to activate some new learning, exploring some new concepts with remembering how using those tools that we just talked about in terms of multiplying using the area model and organizing our information like that. As always, asking the question, when will I use this in real life? Today, and in general, we are building patience and frustration tolerance. So though you might not use factoring or multiplying binomials, which we'll come to in everyday life, these can be frustrating processes. They can be confusing processes. And so working through them, we're building patience and frustration tolerance, which I can guarantee are going to be skills that you are going to need in your life someplace. All right, first we're going to recap some vocabulary. I've been using words and realizing that maybe they're not common words for everyone. So to make sure it's important for us to know that we're all on the same page. So variable is a letter that represents an unknown value. A term is a number or the product of a number and one or more variables raised to exponents. We're going to look at examples of what these are. These are just the definitions. A coefficient is a number multiplied by a variable, including the invisible one. Sometimes we can't see what the coefficient is, and that's because it is 1. A constant is a number with no variable. It's not being multiplied by a variable. And the degree is the highest exponent in your expression. So let's look at an example of what all those means. So we have 7x to the exponent 5 plus x squared times y squared minus 4xy plus 7. So there are 4 terms in this expression. 7x to the 5th is our first term. X squared y squared is our second term, minus 4xy is our third term, and 7 is our fourth term. So you can think of your terms as your groups of numbers and letters that are broken up by your addition and subtraction signs. Those are what sort of break up between our terms. You have to also remember that the sign that is in front of your term goes along with that term. So if it's a plus sign, that means that that term is positive. If it's a minus sign, that means that term is negative. The coefficients of term 7x to the 5th is 7. That is the number that's in that at the beginning of that that's being multiplied by the variable. The coefficient of term x squared y squared is 1 because we have that invisible 1 that we aren't writing down. Mathematicians, like to say, are lazy. If we don't have to write something, we won't. The coefficient of the term negative 4xy is negative 4. The negative sign goes with the coefficient, goes with the number. And 7 is the constant term, the number that has no variables attached to it, so it's a constant. The degree is 5 because high is the highest exponent in this expression. I have written it so that that degree, the 5th degree, comes first. It isn't guaranteed that it's always going to be in the first position of your expression. It could be anywhere. It just has to be the highest exponent. Okay, so other language that we've been using are polynomials. So what is a polynomial? Polynomials are terms that have variables with whole number exponents. So negative 10a to the 5th is a polynomial because the variable has an exponent of 5, of positive 5. 2x to the negative 3 3 is not a polynomial because the variable has a negative exponent. Right now, we don't know what that means. It'll mean something in a couple of days. 4 divided by t squared is not a polynomial because the variable is in the denominator. So it has to have your variable has to be in the numerator and has a positive exponent. So then there's types of polynomials that we're going to be talking about frequently. So it's important to know when I'm using that language what it is we're talking about. A polynomial has one term. 5a squared is an example of a monomial. -3 is an example of a monomial. 9x to the 4th y is a monomial. So you can have multiple numbers or letters, but it just having one term is what defines a monomial. A binomial has two terms. So 6b to the 5th plus 2c to the 3rd is a binomial. It has two terms. 6b to the 5th is one term and 2c cubed is another term. Another example of binomial is 7y squared minus 12. 7y squared is one term, minus 12 is the other term, so we have two terms. Therefore, it's a binomial. A trinomial has three terms, negative 15x cubed plus 2x squared minus 5 is trinomial, has those three terms. Negative 15x cubed, one term, 2x squared is another term, minus 5 is a third term. Another example is 2x squared minus 8xy plus 4y squared. Again, three separate terms make it a trinomial. Those are the most common types of polynomials that we're using. If something has more than three terms, we'll just call it a polynomial. We won't give it a specified name. Okay, so hopefully reviewing that language will make sure that as we're going along, you can refer back to that if you need to understand what we're talking about. We're going to be looking at the distributive property first. So we're going to expand. Oh yes, this is on page 9 of your IL book. We're going to be following the same order generally as your IL book. We'll be putting some more information back, understanding a little bit more of the why of things, but we're not mixing up the order that it shows in your book. So we're going to expand 3 times x plus 4. It's important to remember that when we have a number right next to a bracket or a letter right next to a bracket, or even two sets of brackets right next to each other, that is a shorthand for multiplication. So to expand, when math textbooks or questions say expand, what we just mean is to multiply, is it to expand out what we can do. So thinking about our area model, 3, I'm showing here on the screen as 3 ones, and then x plus 4 is an x, which is an unknown amount, but so it's in, and then 4 ones. So when we're multiplying that, like it's saying that we have 3 groups of x plus 4. So how we can think about that is that we have 3 times x, so we have 3 x's, and then 3 times 4, because we have 3 groups of 4 as well. So 3 times x is 3x, and 3 times 4 is 12, so we end up with 3x plus 12. Those are not like terms, so we can't add them together. If you are looking on the screen, you can see that those x's and the 1 units look really different. We can't say that we have a whole bunch of the same thing because they are very different. So our final answer is 3x plus 12. And that's what it means when we say expand. We are just multiplying parts. We multiply each term at the brackets by the term that's outside the brackets, because we're saying that we have 3 groups or however many groups of what's going on inside the brackets. Okay, so that helps us with page 11, question 1. We're only doing one example because there's a lot of other stuff to pack in as we continue forward. So if you need more help with that, then get in contact with me. That is the basis of everything else that we're doing. So if you're struggling with that, let me know and we'll make sure that you understand that before you try to dive into the rest. So we're going to look at the distributive property with two binomials. So binomials, remember, have two terms. So we're going to be multiplying things with two terms. This is on page 11 of your IL book. So using the same sort of strategy, we're going to use, I forgot to say that these are called algebra tiles, these manipulatives that we're using. And I'm going to put a link in the show notes that gives you, there's a free online resource that you can use. So you can have these virtual manipulatives and you can use them to help understand these concepts. So here we have our question is x minus 5 all times x plus 6. So our two binomials are x minus 5 and x plus 6. And we're going to multiply those together. So using our algebra tiles, we are laying out our question. So x minus 5, we can see is an x term and or an x tile, and then 5 -1 tiles. And then x plus 6 is an x term, sorry, an x tile, and 6 +1 tiles. So then if you think back to that area model when we had numbers, we are going to be multiplying our parts together. So if we have x times x, that's like our side lengths are x and x. If we think back to previous lessons, that is the same as x squared. We don't know how many unicorns are there, but we know that we have x squared amounts. So in terms of our writing, how we write that out is that our first step is that x times x equals x squared. Then we're going to do x times our plus 6, and x times plus 6 means that we have 6 x tiles. So we have plus 6x. Then we do our x times -5. And that gives us, this time, that gives us -5 x tiles. So because we have our negative ones times our x means that we end up having -5 x tiles. And then finally, doing -5 times +6 as our last piece. We have a total of -30 when we multiply those two parts together. So that's how we break up all of our pieces and make sure that we're multiplying all of the parts. The most common error when students are multiplying two binomials is that they either forget to multiply some of the parts or multiply some of the parts more than once. So organizing it with your algebra tiles means it's really clear which ones you've already done and which ones you haven't done. You can draw out your algebra tiles. You can use the app to show you. You can have the actual tangible manipulatives. If we were in a classroom, we'd have actual ones we could share. But this helps organize, keeps your information organized. Are we finished? Not quite. So we have to look at our question and we see that we have all of these x terms and we want to combine them because we want to simplify our expression as much as possible. So how we combine them is that we look at our x terms and we say, okay, well, x minus x, we're going to cancel out. They're going to be 0. They are opposites of each other. So we can continue to do that where we can take our tiles, our x tiles, and because we have a positive and negative ones, we cancel them out as much as we can. So we take as many of them away and we are left with just one x tile. Which, if you think about it, if you look at the algebra, we look at just the numbers and all the titles, 6x minus 5x is going to give us 1x. That makes sense to us. So our final answer is x squared plus x minus 30. Those are all the tiles that we have. So again, we can only add and subtract like terms. If we're looking at what we have again in our visual, we can see that those things that we have that are left don't look the same. They aren't the same type of tile, and therefore we can't combine them. So in terms of definition, like terms have the same variable with the variables having matching exponents. So x squared and x, we can't add them together because they have different exponents. And we can see that they aren't the same shape. They're talking about something different. And x and the 1 tiles, negative 31 tiles, we can't add together because x has a variable and the constant tiles don't. But we can see again that they are a very different shape. They're talking about different things. Okay, let's look at another example. This time we have y in our expression. It doesn't matter what our variable is, the same principles always apply. So our question is negative y plus 3 times 2y minus 1. So right now, as we're working conceptually and with some sort of concrete examples, we're going to use our algebra tiles again. We will get to a point where we're just doing algebra, but right now we're starting with understanding what's going on with our concrete example. So again, drawing negative y tile plus 3 1 tiles, and then 2 y tiles plus a negative 1 tile. This sets up our question. So when we multiply negative y times y, we get negative y squared. And we do negative y times y, we get negative y squared. That means that we have negative 2 y squareds. Then if we do negative y times negative 1, we end up with a positive y because a negative times a negative equals positive. This can be something that can be really confusing. On my YouTube channel, I have an example, a video there that shows sort of conceptually why that works. There are lots of great math examples out there, but my video is a little bit different. So if that's a concept that is frustrating for you, go check that out. I will link it in the show notes. Then we're going to do, so far we have negative 2y squared plus y. And then we have our plus 3 times our 2y. So that's going to give us plus 6y. And then we have our our positive 3 times our negative 1. And that's going to give us negative 3. Again, we combine our like terms. This time we can see when looking at the visual that we don't have any negative and positive y's. They're all positive. And so 1y plus 6y is going to give us 7y. So our negative 2y plus 7y minus 3 is our final answer. We can't simplify that any further. So Polypad virtual manipulatives are where you can go and use these algebra tiles. You can set it up so that you can lay them out and multiply them according to your questions. They can be a great tool to use, and it's a free online and app that you can download either on iPhones or on Android devices. I will link all of that in the show notes as well. We're going to also, the other method that we're going to do is if you don't have algebra tiles, or if that conceptually makes sense and you are ready to move on to just doing algebraically, because it's a little bit of a shorter method, or at least easier to write out method if you don't like drawing boxes forever, is that we do the same idea. We can set up in the same way. You can see that it models after the same sort of structure, but instead of drawing on tiles, we're just going to write our numbers. So we have negative y plus 3 times 2y minus 1. So we write it like this, and then we're going to I divide my section between each of my terms, just to sort of, again, keep my information organized. So negative y times 2y is negative 2y. Negative y times negative 1 is plus y. Plus 3 times 2y is plus 6y. And plus 3 times negative 1 is negative 3. So you can see we can still organize the math. We can still do all of the multiplication, organizing it in this little box, and we get the exact same answer as we would when we did the algebra tiles and did it visually. So this is another method that you can use when you're organizing, when you're multiplying your two binomials. So we have algebra tiles is our one method that you can use, or our box method is another tool that you can use to keep your information structured and organized. So now we're going to do the distributive property with one monomial and two binomials. And this continues on page 11 in your IEL book. So one binomial is one term times two binomials, which are two binomials that both have two terms. This is something that students, again, frequently make errors on. So we're going to go through it to understand why what is most common doesn't make any, which is inaccurate. So this 3 in front is what's different. Having this monomial in front is what was different than what we just did. And what students usually do is they multiply it by every single term that they see afterwards. So they do 3 times x, 3 times 7, 3 times x, and 3 times 4. We have to figure out why that doesn't make sense, why that is inaccurate. So we're going to look at a simpler example to figure out why we don't want to do that, where we multiply the monomial, the number at the beginning, by every single other variable and number. So we're going to look at 8 times 5 times 2. Remember that when we have a number or brackets next to each other, in both of these examples, that means to multiply. So what people commonly do is replicating this. What we do, what people commonly do up here with the binomials, is people do 8 times 5 and 8 plus 8 times 2. So if we do that, 8 times 5 is 40, 8 times 2 is 16, so that's 56. But if we think about that, that would be 8 times 5 plus 2. That's 8 times 7, where our 5 and our 2 are added together. We broke it apart into friendly numbers we could think of, and that's the multiplication that we did, which isn't what our original question is asking, right? Our original question is saying 8 times 5 and then times 2. So that's why we can't do it like this, where we multiply each part by our first term, because we end up adding our second terms. So that is why it doesn't work up here with our binomials, is that if we multiply 3 times all of our parts, we're ignoring the fact that we're supposed to be multiplying here. And then we end up adding all of our terms that are in our binomials instead of multiplying our two binomials. So let's look at our example about what is accurate, what we're supposed to be doing. So 8 times 5 times 2 in our brackets translates with our multiplication signs to 8 times 5 times 2. We need to be multiplying at all those steps. So we would do 8 times 5 first, which is 40, and then we would multiply that times 2. So then 40 times 2 is 80. And that's what 8 times 5 times 2 is. So that's what we need to be doing when we're doing our monomials and our binomials, is that we need to be making sure that we're multiplying all the time and not accidentally adding. Okay, so let's look at our example where we're doing the full amount. So we are going to do two different methods. The first method is to do 3 times x plus 7 first. We're going to multiply our 3 times our first binomial. So we can do that with our box method. So 3 times x is 3x, plus 3 times 7 is plus 21. Okay, we multiplied our first two parts. Great. So when we write that down, we write the answer of that multiplication that we just did, and then we're going to continue that in brackets because it's then going to be times x plus 4. So our second step is to then do 3x plus 21, all of that multiplied by x plus 4. So continuing with our box method, 3x plus 21 times x plus 4. So 3x times x is 3x squared. 3x times 4 is plus 12x. 21 times x is plus 21x. And plus 21 times positive 4 is positive 84. So that is the second thing we can write out in our equation. And then now we can combine our like terms to get 3x plus 33x plus 84. So doing the two steps, the multiplication in two steps, gets us to our correct final answer. All right, method 2 is to expand our binomials first to do x plus 7 times x plus 4 first. So we're going to use our box method. X times x is x squared. X times positive 4 is plus 4x. Positive 7 times x is plus 7x. And positive 7 times positive 4 is plus 28. So then when we write that out, we haven't done the 3 yet. So we continue to have the 3. We need to remember that we still need to multiply that. And we put in the rest of our new multiplication out inside brackets. We combine our like terms because that simplifies it. And now we have 3 times all of x squared plus 11x plus 28. So now we're going to multiply 3 times all of x squared plus 11x plus 28. Using our box method, we have 3 times x squared is 3x squared. 3 times positive 11x is plus 33x. And 3 times positive 28 is positive 84. So then that gets us to our final answer, which is the same as what we had in our previous method. So you can do either way. You can do your binomials first and then multiply your monomial, your constant, or you can do your constant and one of your binomials first and then multiply that by your second binomial. It doesn't matter. You're going to get the same answer if you do it correctly, but you just need to pick one of the ways to do that makes the most sense to you. So overall, you need to choose the best tool for you when you're doing these questions. So you can use Algebra Tiles. You can either draw them or use the app or the online method. You can use the box method, and you can even use FOIL, which isn't something that I taught today, but you may be familiar with it from other classes, and it stands for first, outside, inside, last. Even though we didn't talk about it today, you can still use that method if that's something that's really comfortable for you. So all of these methods are valid and will get you to the same answer. You need to choose what's best for you. All right, now's the time to pause the video if you want and do the support questions on page 13, questions 2 through 5 are the material that we just covered. All right, let's consolidate our learning. Highlights of what we did. We have just focused on the polynomials. We haven't gone to the factoring. The factoring is what will come in next lesson. So we did our polynomial vocabulary. We reviewed variable, term, coefficient, constant, and degree, as well as the definitions of polynomial, monomial, binomial, and trinomial. We expanded using the distributive law. So we remember that we multiply each term inside the bracket by the term that's outside the brackets. That was our first step. And then we expanded and simplified binomials using the distributive law, where we did Algebra Tiles and the box method of what we focused on, or you could also use FOIL. Our 6 we've covered today, the first one, so you hopefully can explain and identify polynomial terminology, and that you can multiply binomials. Those are what, if you can do those things, you've been successful with today's lesson. If not, let's do some more practice. So here is a few practice questions. For each of the polynomial, identify the following: type, degree, constants, term, and coefficients. So question A, we have negative 12a to the 6th plus 15a to the 5th minus 8a to the 4th minus 2a to the 3rd plus a squared minus a plus 32. Whew, lots of terms. So this, we would just call this a polynomial. It isn't any of our specific types of polynomials because it has 1, 2, 3, 4, 5, 6, 7 terms. We wouldn't, we don't have a word for that is more specific. Okay, but our terms are negative 12a to the 6th, and then 15a to the 5th, and then negative 8a to the 4th, and then negative 2a to the 3rd, and then a squared, and then negative a, and then 32. Those are all of our terms. Our degree is 6 because 6 is our highest exponent. Our coefficients are -12, 15, -8, -2, 1, because this is an invisible 1 in front of a squared, -1, it's an invisible 1 in front of our negative a, and then our constant is 32. Okay, another example. Example B, t squared plus 25t plus 13. This has how many terms? Let's count them. 1, 2, 3. That makes it a trinomial. Trinomial being, tri being the prefix, which is like tricycle 3. Their terms, we have t squared, and then 25t, and then 13. Our degree is 2 because 2 is our highest exponent. Our coefficients are 1. 1 is the invisible 1 in front of t squared, 25, and then 13 is our constant. Okay, so that's our vocabulary. All right, some more practice questions. All right, we're going to expand and simplify negative 4x times, negative 4x. This is confusing to say it out loud. Negative times 4x minus 11. So that negative at the front is like -1. So we're going to be multiplying that negative times our 4x and the negative times our -11. So you can write it out as -1 times 4x, then -1 times -11. And then that ends up being -4x. A negative times a negative is positive plus 11. It is extremely common for students to have the negative, change the 4x sign to get -4x, but then forget or don't apply the negative to the second part or the further parts. So they would end up with -4x minus 11, which would be incorrect. You need to make sure that you change the signs on both. All right, and then we want to expand and simplify this question, which is 4y minus y plus 2 times 3y minus 1. Again, it's really hard to say these and know what we're talking about because we have these two binomials. We're going to multiply those together first, and we're going to do that with the box method over here. So y plus 2 times 3y minus 1. So we have y times 3y, which is 3y squared, y times -1, which is -y, 2 times 3y, which is 6y, and 2 times -1, which is -2. So to write this out, our 4y we're still having, and our negative we're still subtracting. So then we need to think about the fact that this, when we're multiplying, we're going to put inside brackets. So we have 3y squared minus y plus 6y. You could skip it and just write 5y if you wanted to, but I'm going to write it all out so that we can see. So then 4y, we're going to combine our like terms, 3y squared plus 5y minus 2. So then this, we have that negative, we're subtracting this whole thing. So again, just like we did up here, where we subtracted, we need to change the signs on all of our terms. So we have 4y take away 3y squared, then apply this negative to the 5y. So take away 5y, and then apply the negative to negative, take away 2. So then we're actually adding 2. And that's another common mistake that people make. They might catch it when it's separate question, but when it's within something, they might miss it and just apply this negative to the first part. So then we want to combine like terms. So 3y squared, there's no other y squared terms, so that's going to stay y squared. And then 4y take away 5y is going to be -y plus 2. So we've combined all our like terms and we are finished. Okay, next question. Write a simplified expression for the area of the object below. So we have a rectangle with dimensions of 8x and x plus 5. So our area of a rectangle is equal to the length times the width. So the length we can say is 8x times x plus 5. So then thinking about, we could either write it as our box method, or you can just think about it using some arrows to keep track. So 8x times x is 8x squared. And 8x times 5 is plus 40x. It is totally fine if you need to use a calculator to do your multiplication. It's all good. And that gives us our final expression of 8x squared plus 40x is our simplified expression of the area of this object. We can't simplify it any further. We don't have any more information. So those are, we sort of whipped through those last practice questions to get them in before our lesson ends. You can go back to the video and slow things down and pause things if you need to. We're going to continue with lesson 2 in next class to do the second part of the factoring part. It's going to be a jam-packed class as well. If you have any questions, contact me at calling and leaving a message for me at the office at 807-737-1488 or toll free 1-800-3703. You can get me directly at bronwyn.slate, spelled BRONWYN.SLATE at nnec.on.ca. And you can find me on Facebook at first name B Slate, last name Wahsa, or the same, my YouTube channel is B Slate Wahsa, where you can find this video and the previous lessons, as well as other videos that help with these concepts. My office hours for this term are Monday through Friday, 8 a.m. to 2 p.m., but I am able to connect outside of that time if you desperately need me to. Thanks so much for joining me today, and have a good night.